Hi, my name is Siti Nur Ainul Aina binti Mak Ilyas, and I'll be explaining about the objectives of this topic. So there are 4 objectives, which is the first one is to determine the retention times of N-butanol and 2-propanol. Second one is to identify the components present in a standard mixture based on the retention time. The third one is to identify the components present in an unknown sample, and the last one is to determine the effect of temperature on retention time and resolution.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Nuraman Iman binti Hanizam Shah. So for today's presentation, I'm going to present about the introduction of our video presentation. So firstly, what is gas chromatography? Gas chromatography, or GC, is a technique used to separate components in a mixture based on their volatilities, which are related to difference in boiling points. In this technique, the sample is first vaporized and then carried through the column by a gas known as the carrier gas. As the sample travels through the column, its components are separated between a mobile gas phase and a stationary phase inside the column. So, the common carrier gas used in GC include helium and nitrogen. Next, the movement of the carrier gas through the column is controlled by pressure supplied from a compressed gas cylinder. Next, we will continue to learn about the type of gas chromatography. So, there are 2 types of gas chromatography. The first one is gas liquid chromatography, or GLC, and the second one is gas solid chromatography, or GSC. So, we will look one by one. Okay, for the first one, for the GLC, the mobile phase is a gas and the stationary phase is a liquid, and they use a partitioning as their separation mechanism. And for the second one, the GSC, the mobile phase is a gas and the stationary phase is a solid, and the separation mechanism used in it was adsorption. Last but not least, we will learn about the principle of gas chromatography. So firstly, in gas chromatography, the analysis begins when a small amount of sample is injected into the inlet, also known as the injector. At this point, the sample is heated and vaporized before entering the chromatographic column. Then, the vaporized sample is then carried through the column by a flow of inert carrier gas, which act as the mobile phase. Then, as the sample moves through the column, its components travel at different speeds. This causes the components to separate from each other as they pass through the column. Finally, the separated components reach the detector, where they are detected electronically and recorded as the chromatograph.
My name is Izzatul Huda binti Muhammad Marbawi, and my student ID is 2023-467196. Here is the instrument in a gas chromatography. Each of them have different functions to work together to function well in a gas chromatography. Firstly, injector. This is the starting point where the sample is volatilized and introduced into the carrier gas stream. A syringe is used for injecting the sample into the injection port. The role of carrier gas is to carry the sample molecules along the column while they are not dissolved in or absorbed on the stationary phase. This component is inert and does not interact with the sample. Thus, GC separation cell activities can be attributed to the stationary phase alone. Gas flow regulator controls and stabilizes the carrier gas like helium and nitrogen, pressure and flow rate, ensuring consistent delivery. Gas is a column. This is the place where the separation of sample components occur. The detector then senses physical-chemical properties of the analyte and provides a response, which is amplified and converted into an electronic signal to produce a chromatograph. Lastly, data analysis. Although it is not a physical part of the chromatograph, the data system plays a role in processing and interpreting the signal generated by the detector. The software allows the users to quantify and identify the component of the samples based on the retention time and per areas.
Hi, my name is Aisha. So I'm going to present about the results and also the discussion. So for the result, I'm going to present for the butanol results. So for butanol results,
there are one peak and the compound is butanol and the retention time is 6.043. Next is propanol. So the first peak is the compound for the first peak is propanol and the retention time is 2.724. Next is the results for the standard mixtures. So for the first standard mixtures is there are two peaks. So the first peak is the retention time for the first peak is 2.692 and for the second peak is 5.903. For the second standard mixture, there are two peaks. So the first peak for the retention time is 3.294 while the second peak is 2.269. For the standard mixture 3, there are two peaks too. So the first peak is 1.952 and the second peak is 2.225. Next, I'm going to present about the effects of reducing and increasing the column temperature on retention time and peak resolution. So, column temperature has a significant effect on retention time and peak resolution in gas chromatography. When the column temperature is increased, the compounds become more volatile and move faster through the column. As a result, retention time decreases. However, peaks elude closer together, which can reduce peak resolution and can cause overlapping peaks. In contrast, reducing the column temperature slows down the movement of compounds through the column. This increases retention time and allows more interaction between analytes and the stationary phase, leading to better separation and improved peak resolution. Therefore, an optimum column temperature is required to achieve a balance between shorter analysis time and good peak resolution.
So, to wrap it up, first we successfully identified the unknown sample. It contains 2 propanol with retention time of 2.724 minutes while N-butanol at 6.043 minutes. Second, by matching this retention time, we are actually able to confirm the alcohol in both standard mixture and the unknown sample. Third, we saw the temperature is a key parameters, especially when changing its tune by the separation between the compound. And finally, this experiment confirmed the gas chromatography with an FID detector is an effective method for separating and identifying low molecular weight, which is MW, alcohol like this. And yeah, that's all for our presentation. Thank you for watching.